Dinosaurs were amazing creatures. They ruled the Earth for millions of years. Some were huge, like Brachiosaurus, taller than a 4-story building. Others were fierce predators, like Tyrannosaurus rex, with teeth as long as bananas. But about 66 million years ago, the dinosaurs vanished. What happened to these giants? Scientists have been trying to solve this mystery for a long time. One of the most famous theories is the asteroid impact. Imagine a giant rock from space bigger than Mount Everest crashing into Earth. This impact would have caused massive earthquakes, tsunamis and wildfires. The sky would have darkened with dust, blocking the sun for years. This theory is supported by evidence like a huge crater in Mexico and a layer of rare metal called iridium found all over the world. Iridium is rare on Earth, but common in asteroids. Another theory suggests that massive volcanic eruptions played a major role. Imagine volcanoes erupting continuously for thousands of years. These eruptions would have released poisonous gases and ash into the atmosphere, changing the climate and making it difficult for dinosaurs to survive. Scientists have found evidence of massive volcanic activity in India that occurred around the same time as the dinosaur extinction. These eruptions created vast lava flows called the Deccan Traps. While the asteroid impact and volcanic activity are considered the most likely causes, other factors might have contributed to the dinosaurs' demise. Changes in sea level, climate change over a long period, and diseases could have weakened the dinosaurs, making them more vulnerable to extinction. It's likely that a combination of these factors led to the end of the dinosaurs' reign. The extinction of the dinosaurs teaches us that even the most dominant creatures can be vulnerable to changes in their environment. Understanding these past events helps us appreciate the delicate balance of life on Earth and reminds us of the importance of protecting our planet. Gap 2S. While the asteroid impact is often spotlighted, the role of volcanic activity in the extinction of dinosaurs cannot be overlooked. Imagine a world where, for hundreds of thousands of years, volcanoes spewed lava and ash, filling the skies with dark clouds that blocked out the sun. This cataclysmic scenario is not just a figment of imagination, but is supported by fossil evidence and geological data. Cut to animated sequence of volcanic eruptions, Gap 3S. Massive volcanic eruptions, like those in the Deccan Traps of present-day India, released vast quantities of sulfur and carbon dioxide into the atmosphere. These gases would have caused acid rain, cooling of the planet, and a dramatic shift in climate, making it difficult for dinosaurs to survive. Cut to expert interview. Expert 1. The sheer scale of the volcanic activity during this period was unprecedented. We're talking about eruptions that lasted for thousands of years, creating an almost inhospitable environment for life. Cut to fossil evidence. Gap 3S. Fossil records show a significant decrease in dinosaur populations, coinciding with these volcanic events. The thick layers of ash found in sedimentary rock provide a grim testament to the harsh conditions that these creatures faced. Cut to expert interview. Expert 2. When we analyze the fossil evidence, we see a clear correlation between the timing of volcanic eruptions and the decline in dinosaur species. It suggests that the volcanic activity played a crucial role in their extinction. Gap 3S. The combination of volcanic eruptions, asteroid impacts, and other environmental challenges created a perfect storm that led to the end of the age of dinosaurs. This multifaceted extinction event serves as a stark reminder of how interconnected and fragile our planet's ecosystems truly are. Gap 3S. As we continue to study these ancient cataclysms, we gain valuable insights into the resilience and vulnerability of life on Earth. Understanding the past helps us prepare for the future, reinforcing the importance of environmental stewardship in our modern world. A Gap 2S. While the asteroid impact and volcanic activity are significant factors, the role of climate change in the extinction of dinosaurs is equally compelling. Fade in animated sequence of shifting climates. Imagine a world where climate patterns shifted dramatically, creating an environment that was increasingly hostile to the survival of these magnificent creatures. Gap 3S. Over millions of years, the Earth's climate underwent substantial changes. Cut to expert interview. These shifts affected the availability of food and water, forcing dinosaurs to adapt or perish. The fluctuating temperatures and changing ecosystems would have been a relentless challenge for even the most resilient species. Cut to expert interview. Expert 1. Climate change played a pivotal role in the extinction of many dinosaur species. As their habitats transformed, they were unable to find the resources they needed to survive. This gradual but persistent pressure led to a decline in populations long before the asteroid impact. Gap 3S. Cut to animated sequence of droughts and floods. Fossil evidence supports this theory. In many regions, we find signs of prolonged droughts and intense flooding, conditions that would have been catastrophic for large herbivores and the predators that depended on them. Cut to fossil evidence. Gap 3ES. Layers of sediment reveal periods of extreme climate fluctuations. These layers show a pattern of stress on dinosaur populations, with fewer fossils found in times of severe environmental change. Cut to expert interview. Expert 2. When we examine the sedimentary layers, we see evidence of repeated climate stress. These changes in the environment would have made it incredibly difficult for dinosaurs to thrive. The fossil record gives us a window into the challenges they faced. Gap 3S. Cut to reflective montage of animated sequences and fossil evidence. The story of dinosaur extinction is not just about a single catastrophic event, but a series of interconnected challenges. Climate change, volcanic activity, and asteroid impacts all played a role in creating the perfect storm that led to their demise. Gap 3 says, as we reflect on the extinction of dinosaurs, we are reminded of the delicate balance that sustains life on Earth. Understanding the past helps us appreciate the complexity of our planet's ecosystems and underscores the importance of addressing climate change in our time. Fade out to thought-provoking music. Gap 3S. The lessons of the past are clear. Resilience and adaptability are key to survival. By studying the extinction of dinosaurs, we gain insights that can help us protect the future of our own species and the myriad forms of life that share our world. Fade to black. Our Gap 2S. Amidst the myriad of theories surrounding the extinction of the dinosaurs, one stands out with a dramatic flair: the asteroid impact theory. Fade in animated sequence of an asteroid hurtling towards Earth. Imagine a colossal space rock approximately 10 kilometers wide racing towards our planet at an unimaginable speed. Gap 3S. This cataclysmic event is believed to have struck the Yucatan Peninsula in what is now Mexico, creating the infamous Chicxulub crater. Cut to expert interview. Expert 3. The evidence for the asteroid impact theory is compelling and widespread. The Chicxulub crater is a smoking gun, providing a direct link to the massive asteroid that collided with Earth around 66 million years ago. Gap 3S. Cut to animated sequence of the asteroid impact, showing the initial explosion and subsequent shock waves. The impact would have unleashed an explosion equivalent to billions of atomic bombs, sending shockwaves across the globe. Cut to expert interview. Expert 4. The immediate aftermath of the impact was devastating. It triggered massive wildfires, tsunamis, and a nuclear winter effect, where dust and debris blocked out sunlight, drastically cooling the planet. Gap 3S. Cut to animated sequence of global wildfires and tsunamis. The skies darkened, temperatures plummeted, and photosynthesis ground to a halt. Gap 3S. This sudden and severe climate change would have been catastrophic for the dinosaurs and many other forms of life. Cut to expert interview. Expert 5. The fossil record shows a distinct layer of iridium, a rare element found in asteroids at the boundary between the Cretaceous and Paleogene periods. This iridium layer is a key piece of evidence supporting the asteroid impact theory. Cut to fossil evidence showing the iridium layer. Gap 3S. This layer of iridium, found in sedimentary rocks worldwide, marks the end of the age of dinosaurs and the beginning of a new era. Cut to reflective montage of animated sequences and fossil evidence. Gap 3S. The asteroid impact theory, with its dramatic evidence and global implications, paints a vivid picture of the final chapter in the age of dinosaurs. Gap 3S. As we delve into this theory, we are reminded of the fragility of life and the profound impact that cosmic events can have on our planet. Fade out to thought-provoking music. Gap 3S. The story of the dinosaurs' extinction is a powerful testament to the interconnectedness of Earth's systems and the forces that shape our world. By understanding these events, we not only unravel the mysteries of the past, but also gain valuable insights into the potential future of our own planet. Fade to black. Gap 2S. As we have explored, the extinction of the dinosaurs is a complex event with multiple contributing factors. Fade-in montage of animated sequences from previous scenes. Each theory presents a piece of the puzzle, and together they form a more complete picture of this dramatic period in Earth's history. Gap 3S. Cut to expert interview. Expert 6. While the asteroid impact is a significant and well-supported theory, it's important to recognize that it wasn't the sole cause of the dinosaurs' extinction. The interplay of volcanic activity, climate change, and other environmental stresses also played crucial roles. Gap 3S. Cut to animated sequence of volcanic eruptions. The Deccan Traps in India, with their prolonged volcanic eruptions, released vast amounts of lava and gases, contributing to a changing climate. These eruptions likely led to a greenhouse effect, causing temperatures to rise and creating inhospitable conditions for many species. Gap 3S. Cut to expert interview. Expert 7. The combination of volcanic activity and the asteroid impact would have created a 1-2 punch. The initial warming from volcanic gases, followed by the cooling from the asteroid's dust and debris, would have created extreme and fluctuating climates. Gap 3S. Cut to animated sequence of fluctuating climate conditions. These extreme conditions would have been too much for many species to adapt to, leading to widespread extinction. Gap 3S. Cut to expert interview. Expert 8. It's also worth considering other factors such as sea level changes and the shifting of continents. These gradual but significant changes would have altered habitats and ecosystems, adding further stress to dinosaur populations. Gap 3S. Cut to animated sequence of sea level changes and continental drift. The combined effects of these various factors created a perfect storm, culminating in the end of the age of dinosaurs. Gap 3S. Cut to reflective montage of animated sequences and expert interviews. As we piece together these theories, we gain a deeper understanding of the intricate web of events that led to this mass extinction. Gap 3S. Cut to expert interview. Expert 9. The extinction of the dinosaurs serves as a reminder of the dynamic and ever-changing nature of our planet. It's a testament to the interconnectedness of Earth's systems and the profound impact that both internal and external forces can have on life. Gap 3S. Cut to reflective montage of animated sequences and fossil evidence. By synthesizing these theories, we not only honor the scientific quest for knowledge, but also reflect on the fragility of life and the resilience of Earth's ecosystems. Gap 3S. Fade out to thought-provoking music. In understanding the past, we equip ourselves with the knowledge to better navigate the future, ensuring that the lessons of history guide us in our stewardship of this planet. Fade to black.